Ecoholics. So there is this new series where I have been doing previous year questions from DSE past years. So I have done few solutions before this video. If you want to see them, please go to the link in the description box. So in today's video, I'm going to do question number 21 from DSE past year 2020. So let's just see the question. The question reads that consider the following game for players 1 and player 2. Player 1 moves first, so the first player is player 1 and chooses L or R. So player 1 has two moves, that is L or R. If she chooses L, then the game ends and the payoffs are 0. So if the player will choose this end, that is 1, the game is gonna end there and the payoffs will be 1-0. So in payoffs, the first digit, the first letter, the number we write is for player 1 and the second payoff is for player 2, where the first entry is 1's payoff and the second entry is 2nd's payoff. If she chooses R, but if the player 1 chooses R, then 2 chooses U or D. So if they come to this node where 1 is choosing R, then what happens after this? Player 2 is making a move. So the player 2 can make choices between U and D. So if she chooses U, so if U is chosen by the player 2, then the game ends and the payoffs are 0-2. So if the player 2 goes with this U, then again the game will end and the payoffs will be 0-2. But if she chooses D, then 1 chooses L or R. So if the D is chosen, then again 1 will jump in and she's gonna make a new choice. Again, L or R, like this. So if she chooses L, then the game ends and the payoff are 4-0. But if she chooses R, then the game also ends and the payoffs are 3-3. So that's the thing. So what we need to find? We need to find this game has 1 Nash equilibrium in pure strategies, 2 Nash equilibria in pure strategies, 3 Nash or no Nash. So we need to find the number of Nash equilibria in pure strategies. So this is the game. This is how my game is working. So I have drawn it here also. That's how. So player 1 comes and make a choice between L or R. So if she goes by L, games end. But if she goes by R, then player 2 will make a choice between U and D. And if she chooses U, game end here. But if she chooses D, then again player 1 will come and she will choose between L and R. So that's the game. So if we have to get into the answer, that is we want to find the Nash equilibria, we need to write down the strategies, the moves of both the players. So player 1 is moving twice, but my player 2 is moving just once. So let me write this table. So player 1 is moving like this. Like the player 1 can take L, R here as well as L, R here. So I can write the strategies of player 1 like this. So L, L, that's the strategy of my player 1. So in this column, I'm gonna write the strategies of my player 1, L, L. The other strategy is L, R, because he can choose L here and then the R is another on this node. So if on the first node she chooses R, that's also a strategy. And she can choose L here and then R, R. So these are the 4 strategies of my player 1. Second player has only 2 strategies, that is U and D. So I write U and D here. So I have to write the payoffs of both the persons. So if the person 1 chooses L, the game will end there only. So whatever is the strategy of second player, that doesn't even come to the move. So that means the payoff is gonna be 1-0. So same again, 1-0, because if the first person is choosing L, the game is ending there only. It's not even moving forward. So for this L and L at the first move, the payoffs are gonna be 1-0, 1-0. But if the first person at the first place, she chooses R. If she chooses R, so we are moving on this node. After that, there are 2 nodes again, U or D, that's happening. So if the first person chooses R but the second person chooses U, what will be my payoff? It will be 0-2. So I will write 0-2. 2 here. But again, if the first person chooses R, but the second person chooses D. So again, after choosing D, the first has to make the decision. So first is making decision. At the second node, what is the decision of first person? The first person is choosing L. So it means R. Clear? First move pe we have R, but second person is choosing D. So we like this. And then at the second node, this first person is choosing L. So we will move in this direction. So what is the payoff? It's 4-0. Come to this one. Choosing R, second person choosing U. So the game ends there, 0-2. Then first person choosing R, second choosing D, and again the first person is choosing R. So R. So what is the payoff? It's 3 and 3. That's our payoffs. Clear? So now to find the Nash equilibria, we want to see that none of them deviate from their strategies. So how do we find Nash equilibria? So we keep the strategy of one player constant, and then we think what is going to be the best response of my second player. So if I do this, if I keep the L, that is the L move of first player as constant, and then see what is the best response for second player. It's U or D. So I'm keeping this thing constant and then checking. So we are considering the second person. Second person's payoff is maximum where? 0 here, 0 here. So they both are equal. So I just put a dot to say that both are the best responses. Let's come to this move of player 1. So first I keep player 1's responses constant, and then I will see the best response of second person. Then I will do the vice versa. I will keep the strategies, the moves of second player constant, and I will check the best response for my first person. So keeping this thing constant. So what is the best response for second player? Both again 0, 0. So dot here, dot here. Coming to the third one, third move of the third strategy of my player 1. So here, if I keep, I'm moving in this row, I'm keeping this thing as constant. So what is the best response for second player? If it chooses U, if she chooses U, she's getting 2. But if she chooses D, she's getting 0. So she will definitely choose 2. So 2 here. Then coming to here, again the best response is 3, 3, because if the first person is choosing this strategy, R, then second best response, second person, player 2 payoff will be maximized when she chooses D, because then she's getting 3. But if she chooses U, she's getting 2. So that's the best response. The dot ones are the best response of my player 2. Now coming to best response of player 1. So let's keep U constant. This column I'm keeping constant, that the player 2 is constant in its strategy and she's only choosing U. So what is the best payoff this person, this first person can get? So if this is the constant, where is the payoff of player 1 is maximizing? 1, 1, 0, 0. So where is the maximization happening? At 1, 1. So I'm using a star for player 1's best response. So if the player 2 chooses U, the player 1 will be choosing some LL or LR. Then coming to the D, so if the player 2 chooses D, what is the best response? So player 1 gets 1 here, 4 here, 3 here. So what is the best response? Best response is this one. So how to find Nash equilibria? Wherever the best responses of both the persons are same, both the players, that's my Nash equilibria. That means where I have both this dot as well as star. So both are common. So that is a place where both will not be deviating from it. So we have how many places where I'm getting a dot also and a star? That's I'm getting at 2 places only. This one and this one. So it means how many Nash equilibria we have? We have 2 Nash equilibrium in pure strategies. That is LL and LR. And both the Nash equilibrias are giving me same payoff. That is 1 and 1, 0, 1, 0. So I will choose the option which says that I need 2 Nash equilibria. So the option is B, that 2 Nash equilibria in pure strategies. That is my correct answer. So this was the solution to question number 21. If you want to see more solutions, Please like, share and subscribe to the channel. Thank you everyone.